Hello, we are on Unit 3A.2. There are two parts to this unit, Part A and Part B. Day 1, we're going to do examples number 1 through 6, and it's going to go on page 78 of your handy-dandy notebook. Day 2, we will be doing examples number 7 through 15, and that's going to go on page 79 of your notebook, along with page 80 for our unit circle. Okay, so if you're ready, set, let's go. All right, so we're on 3A.2 Part A, sine, cosine, and tangent, and we're going to be focusing on the vocabulary for trigonometry. So let's get this started. And a reminder again, this is page 78 of your notebook. Okay, so sine, cosine, and tangent are terms that you've heard in geometry. And why are they so important? Well, engineers, artists, pilots, carpenters, golfers, what do they all have in common? Well, they all use angles at some point in their careers, okay? There are times we can estimate an angle like a golfer on his tee shot, but when you are constructing, building bridges, homes, you need precise measurements, okay? And that's where trigonometry comes in. And thus we begin our official journey with trigonometry. So we're going to start with our basic property of angles and their measures. Up first is the vocabulary that you need to be comfortable with. So our first term we're going to talk about is standard position. Standard position is telling you an angle whose vertex is at the origin. And so at the origin, and it begins on the positive x-axis. So right here, this is its standard position. This is in standard position, and then it goes counterclockwise to be positive, clockwise to be negative, okay? This side right here, this is our initial. Let me highlight, not underline. Okay, so this is our initial side. So that's the initial side in standard position. Then we have our terminal side. Your terminal side is the ray. So remember, the ray starting goes on forever. Or the side of the angle where it's no longer on the x-axis. So where it stops. So this is our terminal side. Okay. Coterminal angles are two angles in standard position that are going to have the same terminal side. So this is an angle right here. We're going to call this theta. So if you're in physics, or you are, remember, or maybe your teacher should have used, but they call theta is an unknown angle. So this is going to be our positive theta, and it has a coterminal angle that either is going to go around infinitely. There's infinitely coterminal angles because you're either going positive in a counterclockwise motion. So either you're going like this, you're either going and coming back 1, 2, 3, 360, 360, and then counterclockwise, which is creating larger positive, right? Or you're going to go clockwise and creating smaller valued angles because they're negative, right? That's what coterminal is saying. So for this problem here, for this one here, its coterminal would be the angle that shares where it ends would be the negative going this way, right? So to find that, we would take 360, we would do theta minus 360, and that value would equal the coterminal. Okay? They have the same terminal side. And then the unit circle whose radius is 1 unit. So that means R equals 1 unit. So from the origin to the outside of the circle, R equals 1 unit. Because of this, we can then go around and label all of our points right here. So if I'm 1 unit away from the origin, then that means I'm at 1, 0. I'm 1 unit away from the origin, so I'm at 0, 1. I'm 1 unit away from the origin, so I'm at negative 1, 0. And I'm 1 unit away from the origin, so I'm at 0, negative 1. Okay? So that is how our points on the plane for our unit circle come into play. Those are our, we're going to learn those are our quadrantal coordinates. And we'll dive a little deeper. So let's keep going. Positive and negative angles. So as I mentioned, when you have positive angles come from rotating in a counterclockwise direction. Negative angles are from rotating in a clockwise direction, okay? So if you're going clockwise, that's negative, not positive. I know it may take your brain a little bit to undo that, what you think how it should be, but trust the process, okay? Now we're going to dive deeper into coterminals. So two angles in standard position that have the same terminal side are called coterminal angles, okay? We can find an angle that is coterminal to a given angle by adding or subtracting one revolution. One revolution means I've made a complete circle. So you learned that a complete circle is 360 degrees, right? So one revolution means that we've gone 360 degrees, okay? So any given angle has many coterminals. There's infinite coterminal angles, okay? So for example, if beta, our angle equal 36 degrees, is coterminal to all of these followings. That's because I've added and subtracted 360, right? So if I have 36 plus 360, that's how we get 396. And then plus another 360, that's how we get 756. However, if I go the other way, to get our negative, I would have 36 minus 360. That's going to give me the negative 324. 360, another minus 360, that's going to give me negative 284. Now, when you're repeatedly adding or subtracting the same value, that's multiplication, right? So we're multiplying by some value of 360 to find our coterminal. So for example, here, if it says draw the angle theta equals 220 and label your theta prime, your change, right? So first off, if I'm rotating, if this is where I start, this is my 0 degrees. And we know that one revolution is going to bring me back to 360 degrees. There are 4 quadrants, and these 4 quadrants are divided into, I wrote the wrong thing right there. You see nothing. And 2 equal parts, right? So if this is 360, 360 divided by 4 means that each one of these quadrants is 90 degrees, right? So, and that makes sense because they're perpendicular, right, at the origin. So we have 0 to 90, 90 to 180, 180 to 270, and then we're at 360, correct? So if I need to draw 220 degrees, what quadrant is that going to end up at? If you set quadrant 3, you are correct because 220 is between 180 and 270. Okay, so here is my initial side, my initial ray, and I'm going to rotate here about a third of the way in here, right? And here's my 220. So this is 220 degrees. Now it says find the coterminal angle. Well, there are infinite coterminal angles as we discussed, right? That means that for 220, I can find a negative coangle minus 360 times a number, right? Times a number over and over. Well, I'm only going to be able to graph one rotation. So for this one, we're going to let n equals 1. So we're just doing 220 minus 360 degrees. That's going to give us a negative 140 degrees. So my coterminal angle that I'm graphing here is going to be negative 140, and this is going to be our theta prime. Okay, I can find more by just multiplying, putting in n as 2. I can find my second one, third one, and it just keeps going and going in my clockwise motion. If I wanted to go counterclockwise, instead of subtracting, we would add to have us going in our counterclockwise motion. Okay? All right. So, continuing with that, measuring angles in standard position. So when you're in find the measure of the angles below. We're going to talk about, I'm in counterclockwise rotation, correct? So that means that this was my initial, and I've rotated counterclockwise. So this theta has to be positive. So it's asking, what is this theta? Well, I am 45 degrees from 180. Okay. What this is called a reference angle. A reference angle is how far are you from the nearest x-axis. So our reference angle is 45 degrees. So if I'm here, that means theta is going to equal 180 minus 45. 180 minus 45 equals 135 degrees. Okay, so we're going to do that again. This time we're going reverse, right? Clockwise. So that means that our angle is going to be negative. So if we're going clockwise, we're looking for a negative angle. So we know that this negative angle, we've already covered negative 90. And then we've gone another negative 30. So therefore this theta has to be negative 30 plus negative 90, which is going to equal negative 120 degrees. Okay. The other way that you can view it is by finding the reference angle. The reference angle is, if this is 30 degrees, that means that my reference angle here has to be 60 degrees. We're going counterclockwise, so this isn't positive 180, this is negative 180. So what is 60 degrees away from negative 180? Going clockwise. Same thing. It's going to be negative 120, right? Okay, so one full rotation equals 360 degrees. How many degrees, in conclusion, are there in a quarter of a rotation? So a quarter of a rotation would mean we went. Okay, so I've been referencing the word reference angles, right? Referencing the reference angles. Now we're going to dive a little bit deeper into reference angles. So given an angle in standard position, its reference angle is the acute angle formed by the terminal side of the given angle and the x-axis. Way back in geometry, you learned that a cute little angle means that it's less than 90 degrees, right? So the angle at left is 210 degrees. So it's telling us its value is 210 degrees, okay? The reference angle then is asking how far is it from its nearest x-axis. So my nearest x-axis is right here. So how far am I from my nearest x-axis? Well, at my nearest x-axis, that means I've gone half of a rotation. So that's 180 degrees. So to find the value, I'm asking what's the difference between 210 minus 180. And that difference is going to be 30 degrees. So that is my reference angle. All right. Reference angles are going to always be positive. Okay. They're going to always be positive. Cool. All right. So let's look at example number 3. We're going to do A together, but then I would like for you to pause and do B, C, and D on your own. Okay. So drawing each angle and state the reference angle. So 150 is going to be in quadrant number 2 because it's between 90 and 180 degrees, right? So I'm going to draw my initial side. I'm going to rotate. I'm going to estimate it to be right here. And here's my 150 degrees. So my reference angle is asking how far is it from the nearest x-axis. My nearest x-axis is 100 degrees. So how far am I from my nearest x-axis? Well, I am 30 degrees. So my reference angle, some books you may see reference angle referred to as lowercase alpha. It's like a with an exaggerated top and bottom, I guess. So my reference angle equals 30 degrees. And again, this is standing for reference angle. All right, so pause now, and I'd like for you to draw and try the same thing with B, C, and D. All right, let's see how you did. So starting up on B, we have 315 degrees. 315 is going to be in quadrant number 4 because it's between 270 and 360. So here's my initial side. It's positive, so I'm rotating clockwise. And I'm going to be somewhere in here is going to be my terminal side. So remember, it's just a sketch. It doesn't have to be perfect. It just has to make sense to where it's at, okay? So this is my 315 degrees, okay? so 315 degrees. I'm asking what is its reference angle? So how far am I from my nearest x-axis? Well, this is 315, this is 360, right? So how far is 315 from 360? Well, my reference angle would be 45 degrees. I'm 45 degrees from 360. All right, so now we're on to, let's check in your C. This time it's negative. So my initial side is here, but my terminal side is going to be found by going clockwise, right? Because it's negative 120. So when you're thinking about negatives, this would be 0, negative 90, negative 180, negative 270, and then you're going to make your way around to negative 360, right? Everything is going the other way. So I'm going to end up in quadrant number 3. So in quadrant number 3, I'm going to rotate. So we're going 90, and then I'm going to go a little bit more to quadrant number 3, and bam, here is my negative 120. So negative 120 is right here. My reference angle is asking me how far am I from my nearest x-axis, okay? So if I'm at negative 120 and this is negative 180, how far am I from that? Well, my reference would be 60. So I'm 60 degrees from my nearest x-axis, okay? Last but not least, you have 140 here, so I'm going to graph 140. 140 is going to be in quadrant number 2. So in quadrant number 2, I have my initial. I'm going to go 140 degrees. Okay. We're going to pretend that's a straight single ray happening, a ray of sunshine right there, you know. Just a little bold than most, you know. So this is going to be my 140 degrees. It's asking for the reference angle. So I'm asking how far am I from my nearest x-axis? My nearest x-axis is 180. So to find that value, I will be subtracting 180 minus 140 means that my reference angle is 40 degrees. Okay? And that's how reference angles work. Okay? All right, this is important because when we start defining our sine, cosine, and tangent, knowing the reference angle is going to make it so much easier for you to evaluate. Cool. And let's keep going. All right, radians and central angles. So we're going to add on to our vocabulary. So verbal vocabulary that we're going to look at is central angle. Okay, a central angle is an angle whose vertex is at the center of a circle. So what we've been graphing and thus far have pretty much been central angles, right? So center angle, right? So this is the theta for that central angle. Okay, an intercepted arc. The portion of the circle whose endpoints are the sides of the central angle. So my intercepted arc is this piece right here. Okay, that's going to be my arc, my intercepted arc. Okay, whose remaining central angle circle and whose remaining points lie in the interior of the angle. Okay, so view, arc, intercepted. Okay, radian. 1 radian is the measure of central angle of a circle that intercepts an arc equal in length of the radius of the circle. I know that sounds like a lot of words, but it's not terrible, okay? You can use a proportion to convert an angle measure from one unit of measure to the other. So we're going to talk about how to go from degrees to radians momentarily, okay? Now, next part we have here is when we are, okay? So diving a little bit deeper in between these two words, interceptic arc. So a lot of times you may hear this as our arc length. So keep thinking of the word arc length. And typically arc length is represented with the letter S. Okay. There is a formula. Your arc length is S equals R times theta. Okay. The thing here though is our theta value has to be in radians. So theta can't be in degrees, it has to be in radians. And that's what we're going to talk about, okay? For your radians, we can convert our degrees into radians, and we're going to talk about how to do that when we are on the next part, but we're going to look at it here. So we know that we learned circumference. Circumference is 2 pi r, or pi equals d, correct? Correct, okay? 2 pi radians equals 360 degrees. So 2 pi radians means you've gone a whole 360, okay? So pi radians means that you've only gone half of 360, because that's 2. Half of 2 is 1 radian, so that's 180 degrees. So with that in mind, we have our radius. So this is your radius. This would be our theta. Radius is going to be the same. And we know that for this, our r is going to equal 1. Okay? And our r equals 1, and therefore we're going to also have our s. Our arc length here is going to be the same thing. We're going to let this, that's how the proof generally works. So we have pi equals 180 degrees. And we know this simply from using circumference, right? And so therefore 1 radian, so if I go 1 radian of measurement, that's going to be 180 degrees over pi. Okay, all I did was to find the radian value, divide by pi. 1 radian is going to equal 180 over pi. When you plug this in the calculator, it's going to give you a value. That value is theta is approximately, I told y'all my theta start getting a little questionable, 57.3 degrees. Okay, so if 1 radian is approximately 57.3 degrees, we then can approximate the rest by using the very similar formula. But we're going to do it using this so that we can find our exact values. Okay? Theta only equals 1 radian. So theta equals 1 radian only when this is true. Okay? When your radius and your arc length are equal to each other. Okay? So that means that the radius and the arc length are both the same measurement. Hence, in this case, 1 unit. So your radius is 1 unit, your arc length is 1 unit, therefore theta is going to be equal to that. Okay? All right, so let's look at some funness. Converting. So converting between units of angle measured. So to convert from degrees to radians, you're going to multiply by pi over 180. So pi over 180 degrees. And you make sure you simplify. Okay? To convert from radians to degrees, we're going to multiply by the reciprocal, 180 over pi. And again, you want to make sure you are simplifying. Okay, so to start off here, it says find the radian measure of 60 degrees, of a 60 degree angle. Okay, so for this, we know, my thetas. Theta equals 60 degrees, and we want to convert it to radians. To convert from degrees to radians, we said we're going to multiply pi times 180. So this times pi 180. Okay? When you're multiplying, remember, it's the whole number only times the numerator, right? So that's going to give me 60 pi over 180. Well, 60 pi over 180, I can divide both by 10, and then I can divide both by 6. So when I divide 6 by 6, that's going to give me 1 pi. When I divide 18 by 6, that's going to give me 3. So my radian value is pi over 3. It is not necessary to write radian. You can if you want, but this pi lets me know that this is in a radian value. So you can write rad if that helps you, but it is not necessary. Okay? All right, so now we're going to go the other way. So we're going to do 85 degrees to radians. So 85 degrees to radians. I'm going to let you try for a second. So pause, give it a shot. All right, welcome back. Hopefully you really paused and gave it a shot. So theta equals 85 degrees, and we want to convert it to radians. So we're going to multiply 85 degrees times pi over 180, which equals 85 pi over 180. 85 and 180, how can we reduce those? Well, they're both divisible by 5, right? 85 divided by 5 is going to give us 17. 180 divided by 5 gives us 36. They have no more common factors, so this is our radian value, 17 pi over 36. Okay, now, this time we're going radians to degrees. Notice that it's given to us in decimal value. Well, before we do anything, we want to write that not as a fraction, as an improper fraction if possible. So if we have equals 2.5 radians, so we have 2.5 radians, which is the same thing as saying 2.5, right? Which is the same thing as saying 5 halves. So we have 5 half radians, and we want to convert it to degrees. So we're going to take 5 halves and multiply it times 180 over pi. So times 180 over pi. So we're going to do a little bit of simplifying. I personally like to reduce before I multiply. So 2 is going to reduce 180 down to 90. So I'm left with 5 times 90 is 450 over pi. This is my exact degree value. However, this doesn't tell me like the degree. It's saying, okay, this is your exact degree value, plug it in and get an approximation. So when you have something like this, you're going to have to use the calculator to approximate, okay? So 450 divided by pi, I would plug in the calculator and I would get an approximate value of 143 and 239 degrees. Okay, so again, this is my exact, but you're looking for the degree, and you're going to always approximate with the degree unless it states otherwise. All right, so hopefully that wasn't terrible converting between the two. You'll get plenty of practice in your assignment. Okay, in pre-cal and in calculus, you are going to be using radian measurements more so than degree measurements. So we need to be comfortable with identifying those common values, those common measurements, okay? So to start off, I just want to make it what we say when we set a circumference. So when we set the circumference of a circle, a full rotation is 360. And then we talked about the circumference of a circle. A full rotation means you've gone 2 pi. So you went from 0 to 2 pi. That's in terms of radians, okay? Your 2 pi then is broken into 4 equal parts. Do we see those 4 equal parts? So if I take 2 pi and I've divided it into 4 equal parts, I am now going to have half a pi here, correct? Or if you want to do it into the 4 equal parts, this is your, I don't know how else to say it other than, yeah, just divide it in half. So a half would be over here, which would be 1 pi. So this would be our 1 pi. And then halfway between 2 and 1 is going to be our pi over 2. Yeah. So we have pi over 2. I mean, our 0 and pi, we're going to have pi over 2. Halfway between 2 pi and pi is 1.5, which means we have 3 pi over 2. Okay? So when it's asking you to identify and sketch these, keeping this in mind, one full rotation is 2 pi. All you're doing is dividing 2 pi into 4 equal parts. Okay? So here's half a pi, a whole pi. 3/4, I can't talk. A pi and a half, and then a whole pi. 2 whole pies, I'm sorry. All right, so we're going to draw in our negative pi. Negative pi means that I am rotating in a clockwise motion. So to find the value of negative pi, I'm going to have to go this way. So now instead of these being where they are, 0, pi over 2, pi, 3 pi over 2, it's going to be the opposite, right? So this is going to be a negative pi. This is going to be 0. This is going to be negative 2 pi. This is going to be negative 3 pi over 2. And this is going to be negative 1 pi over 2, right? So if I'm looking for negative pi over 4, well, negative pi over 4 is going to be between 0 and a half, right? 1/4 is between 0 and a half, which means that this resides in quadrant number 4. So in quadrant number 4 is where smack dab in the, pretend that I'm going smack dab down the middle. Here's where my negative pi over 4 is. Okay, literally think about it as cutting a pie. All right. Okay, then let's do it again over here. So keeping in mind what we learned in the first one, if I'm looking for pi over 2, so again, we say a whole going around the full circle, that's 2 pi. Going around half of a circle, that's 1 pi. So therefore, if I'm looking for a half of a pi, that's going to be smack dab in the middle. So my half of a pi is going to be this guy, my y-axis. My positive y-axis is where my pi over 2 resides. Okay? And so it's called a quadrantal angle, because it separates the quadrants. Okay? So we're going to write quad because it's not in a quadrant. All right, 2 pi over 3, just like we said here, going all the way around is 2 pi. Going halfway around is pi. If I'm looking for 2 pi over 3, well, 2 pi over 3 is bigger than a half, but smaller than a whole, right? So this is our halfway mark, pi over 2. So we're looking for what's halfway between, right? What's going to be in between these two? It's going to be somewhere, 2 pi over 3 is going to have to be somewhere in here, correct? It's going to be in quadrant number 2. Okay, so quadrant number 2, I'm going to say like here, yeah. All right, so we're going near to 2 pi over 3. All right. The other way to think about it is that your pi is being divided into 3 parts. So if I'm dividing pi into 3 parts, 1, 2, that would be my 2 pi over 3. Okay. All right. So hopefully that wasn't too terrible. Yeah. Okay, for example number 5, I would like for you to pause and answer to the best of your ability these situations. So we have up first, how many radians in each angle of an equilateral triangle? Okay, so thinking about what you know about equilateral triangles. B, the minute hand of a clock travels how many radians in 15 minutes? C, the minute hand of a clock travels how many radians in 10 minutes? D, the minute hand of a clock travels how many radians in 5 minutes? E, what is the measure of theta in radians if x equals 45 degrees? Excuse me. And then F, what is the measure of theta in radians, knowing that this is a supplementary angle? Woohoo, geometry knowledge. Okay, so pause and with your table partners or elbow partner, answer these questions. All right. Thank you for pausing if you really did. So we're going to start with the equilateral triangle. Equilateral triangle means that all angles and sides are the same. Well, way back in geometry, we learned that the interior angle sum of all triangles equals 180 degrees, right? So if you have an equilateral triangle, that means you have an equally angular triangle, so all of the angles have to be the same, which would be 180 divided by 3, which is 60 degrees. So if I have 60 degrees, it wants me to convert 60 degrees into radians. So to go from degrees to radians, that means we're multiplying by pi over 180. So that gives me 60 pi over 180. And like we said before, that's going to be pi third radians, right? Is it necessary to write the RAD? No, it is not. But if it helps you get used to the fact that this is a value, the units are radians, okay? Next, it says, the minute hand on a clock travels how many radians in 15 minutes? Okay, the minute hand. So when you're looking at the minute hand, that's the long hand, right? So your long hand on a clock, I know some of us don't look at an analog clock very much. Okay, pretend that's a perfect circle. And you have your minute hand, and it starts here. And it's going to go 15 minutes. 15 minutes means I go 1, 2, and I'm at 3, right? How much did my minute hand travel from here to here? Well, my minute hand traveled 90 degrees. So this is 90 degrees. And I'm going to convert 90 degrees into radians by multiplying by pi over 180. That's going to give me 90 pi over 180. Divide by 10. Divide by 9. And we're left with pi over 2 radians. Is how much it traveled in 15 minutes. All right, what about in 10 minutes? How much did I travel? Well, if you can't see it as easy, 10 minutes meant that we went doom, 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 right? 10 minutes is would be out of our, how much have we traveled of the circle, right? So when you're thinking about it in terms of that, if I've gone 10 minutes, I've gone 10 out of 60 minutes, that means I've only gone 1/6 of my circle, right? So in terms of degrees, if I've only gone 1/60th of 360 degrees, that means I've gone how many degrees? I've gone 60 degrees, okay? And it wants us to convert it into radians. Well, we've already converted 60 degrees into radians, and we got that equals pi over, that's an ugly 3, but it equals pi over 3 radians. All right, now it says the minute hand of a clock travels how many radians in 5 minutes? Okay, so 5 minutes, I've gone 5 minutes out of 60, which means I've gone 1/12 of the time, right? So I've only gone 1/12 of my rotation to make a full circle. And that means I have 360 divided by 12, which is going to give me 30 degrees. So can I convert 30 degrees to radians? Yes, I surely can by multiplying by pi over 180, which gives me 30 pi over 180. Divide again by 10. 3 divided by 18 reduces it down to pi over 6 radians is how much I would have traveled. Okay, hopefully we're doing good. The last one it says here, well, not last one, second to last, it says, what if the measure of theta equals, find the measure of the angle given that x equals 45 degrees, okay? So x equals 45 degrees. If we know that x is 45 degrees, in radians, this would be pi over 4. Okay? So in radians, we've gone pi over 4. If I've gone, this is a reference angle, right? We talked about this. This is your reference angle. So there's a couple ways you could approach this, but number one is using the fact that this is your reference angle. So if I would normally have gone all the way around, right? My reference angle is saying how far am I from my nearest x-axis. So you have a couple choices here. You could use 45 and subtract it from 360. So you can do 360 minus 45, which is going to give you your 300 and Why did I just have a brain fart? 25? 315. I don't know why I said 45. 315. And then you could take 315 and convert it to radians. The other thing is that use your pi over 4 and the fact that you're now, instead of 360, it's now 2 pi minus pi over 4. Now, this means that you have to be comfortable with fractions. If I have 2 pi minus pi over 4, in order for me to subtract, they have to have a common denominator, correct? So this can be written as, if I have 2 pi, what's another way to write 2 pi with a denominator of pi over 4? Well, I'm just going to multiply the numerator and denominator by 4, and that gives me 8 pi over 4 minus pi over 4. Now, right off the bat, without having to do another conversion, I'm just doing subtraction, I know that my radians is going to be 7 pi over 4. Okay? All right, on the last one, it says, what is the measure of theta in radians? So, when you have angles, on a straight line, that's called supplementary angles, right? Supplementary angles equal 180 degrees. Well, we learned that 180 degrees is pi. So these two angles have to equal pi is what it's asking you. So you know that x plus 5x equals 1 pi. I'm going to add them two together. So I have 1x plus 5x equals 6x. So to get x by itself, we divide by 6. So we get that x equals pi over 6 radians. Okay? As long as you understand that radians is just another unit of measurement and all the skills you already have apply, you will be perfectly fine. Thank you.